Alright, so I have a higher degree polynomial, and it looks kind of weird because here I didn't combine like terms. So let me show you guys by using the Xbox method. I got p of x, and then I'm actually going to combine like terms. I got x to the fifth plus 7x to the third minus 18x. Now basically the Xbox method is for trinomials, which we have now, 1, 2, 3, and the end result is you get binomials. Well, I did tell you a secret. How do I know if it's binomials? Is you get half of this value. Half of 5 should be this value, 2.5. Well, that's not the case. Well, before you do that, you should always, always, always do the GCF first. So if I recognize all of these, what they have in common is the x. So that gives me x to the fourth plus 7x squared minus 18. And now we have something called quadratic like. What is quadratic like? Well, that's where we did the substitution. You guys remember that? Yeah. Something like u equals x squared, you can do that? I'll review the Xbox method with you. Now, I'm not going to tell you use the Xbox method. All we want to know is if you can factor. That's the big idea. Can you factor? Well, I just take inside the parentheses a times c, which is negative 18, and your b value is 7. So a times c, and then your b value. Two numbers that multiply to be negative 18, but add to be 7. 9 and 2. Which one has to be negative? 2. So now I'm going to take those values, top right, bottom left, and then here, inside the parentheses, I'm going to put my first term, and then my last term. Class, I need two terms that'll multiply to be x to the fourth. What is that? X squared times something gives you 9x. Oh, sorry, that should have been 9x squared. Do you see how it's splitting of the terms? Do you see how that matches?
Yeah.
Except for one degree lower. So x squared times something equals 9x squared? Positive 9. And then your greatest common factor here? Negative 2. So, and that checks 9 times negative 2 is negative 18, so I get x squared plus 9, and then x squared minus 9. Raise your hand if you factored yours and you got that. Okay. Let me show you guys the other method now of factoring this. Factoring by grouping just means you take you get to factor a greatest common factor 3 times. Question? That's a 2. Can't see it? Thank you. We're okay? Alright, so my first GCF is what? X to the third. X to the third times x squared plus 9. Okay, here's your hint. I want x squared plus 9, right? What's your GCF? Negative 2x. So then what do I get? X squared plus 9. So I did my first GCF, my second GCF, and now I'm taking my third GCF. What is that? X squared plus 9. And what did I not have in red? Now inside the parentheses here, what do you guys notice? I can pull out another x. Do you see that? Okay, so watch. So let's just say you didn't take out the greatest common factor like over here first. So you have an x, and now I'm left with x squared minus 2. I don't want to lose this x. So this x right here, in math we like to write that in the very front as our leading coefficient. X times x squared plus 9, x squared minus 2. Is that the same thing? Yeah. Alright, let's finish the problem now. So basically we factored. Well, to solve for zeros, I'm going to have to set it equal to 0. So let's set each of these equal to 0. This is our zero product rule. So if you solve this, I got a solution right here. How about this one? How do I solve for x? Pay attention here, slow down. I have x squared equals negative 9. What's the square root? So this is negative 1 times 9. The square root of negative 1 is? The square root of 9 is? And remember, when you're taking the square root of an equation, you have plus or minus. There's actually two problems here. X equals positive 3i and x equals negative 3i. Let's solve over here. Add 2. Take the square root. X equals plus or minus radical 2. Alright, what does that mean? There's 2 of them, right? Is this real or non-real? Okay, let's start with the easy one. Real or non-real? Okay, one real solution. Okay? Class, does it have an I in it?
No.
One real solution.
Real.
Real or non-real?
Real.
Real, there's no I. How many?
2.
2 real solutions. Real or non-real?
Non-real.
Non-real. Non-real means what? Because it has an I in it, right? So I have, pay attention, 2 complex solutions. So let's review what this problem has for us. I have a total of 3 real solutions and 2 complex solutions. Alright, I'm going to show you guys now how to write this nice and clean, and we're all done with this problem. Pay attention. I have the x, and it's kind of simple where you're just putting it into these binomials. If I said x equals 3i, positive 3i, how can I write that as a binomial? Can I write plus 3i? No, well, I wanted a positive, so that'll have to be the negative. Remember when I set it equal to 0? Does that make sense? So this will be x plus 3i. This will be x plus radical 2 and x minus radical 2. So if I had to factor all this, this is my big ol' answer. And now I can answer some questions. Class, how many real solutions do we have?
3.
We have 3. How many complex?
2.
Okay, pay attention. How many times does it cross the x-axis? Remember, it only crosses the x-axis if it's a real solution. So how many? 3. Okay, when it says what is the smallest x-intercept? My numbers are negative radical 2, 0, I'm writing from least to greatest, 0, and positive radical 2. Radical 2 is like 1.4, so negative 1.4 is my smallest. And your book calls this the lower bound of my X-intercepts.